Hey guys, we're going to take a look at parallel lines now, and you saw from the video that one of the questions that comes up is they like to ask us, particularly in the multiple choice section of exams, how many times lines might cross. They don't word it that way. They say, how many times do the lines represented by the following two equations touch or intersect each other? Sometimes they'll say, how many solutions are in the following system of equations? At the end of the day, though, before we figure out or talk about the interpretation of the possible answers, I'm going to tell you without thinking, the first thing we're going to do is we are going to isolate y in both of these equations. We can't answer anything about the nature of parallel lines until we have the equations in y is equal to ax plus b form. So we're going to go ahead and do that right now. Equation number 1, in order to isolate that y, you can see that the 20x and the negative 16 are already on the right hand side of the equation. The only thing we need to get rid of is that 4 being multiplied to our y, and we're going to do that by doing division. So straight up division on all the terms, and we're going to be left with y is equal to 5x minus 4. So we'll talk about what that could mean relative to this line once we've isolated that line. So same deal, we're going to isolate. Now this one has some extra steps because everything is on the left hand side, and I've got to isolate that y with the 36 over here, with that 45x, and then with the coefficient of the y, the 9. So I'm going to start off by adding 36 to both sides, and that'll leave me with 9y minus 45x is equal to positive 36. And then I'm going to add 45x to both sides in order to get rid of that term. So that's going to leave me with 9y is equal to 45x plus 36. And now, of course, I'll do the division of the 9, and that's going to leave me with y is equal to 45 divided by 9. You guessed it, 5x plus 36 divided by 9, you know, is 4. So now that we've got these two isolated, we can actually start to think about what the question means. And so we want to know how many times these lines intersect. Well, let's come down and do our interpretation here. First thing we know already is that lines can't cross twice. That's impossible. If you just take a really quick look at a graph, I mean, no matter where two lines go, because they're straight, they're only ever going to cross in one location, right? So if that's one line over here and that's another line over here, that's the only place that's going to happen. It's not like the line is going to come suddenly and twist and cross in a second location. So we can get rid of that guy. Now, whether they cross once, never, or at infinite points really depends on one key feature to start, and that's the slope. So we're going to start off by analyzing the slope. We know that the slope of this line here is 5. Because we've isolated, we've put it into y equals ax plus b. We have the coefficient of that x is a 5. And over here, we also have a slope of 5. Now, what that means is that these two lines are parallel. And the fact that they're parallel means one of two basic things. It's possible that those two lines, if you think about these two pencils for a second, that those two lines are like these two pencils. They're parallel, like train tracks. They're never going to touch each other because they have the same slope. It's very possible that these lines never, never, never touch. So C is looking mighty tempting right now. We know that A is impossible. It's impossible for these parallel lines to touch one time because the second I change the slope is when that's going to happen, where they have an intersection. I don't have that situation. So once is gone. But I have to pay attention to D for a second because sometimes this pops up. There are two types of parallel lines, right? One set of parallel lines are like my pencils before, right? One like this, and they're parallel, they never touch. And in the other instance, you can have parallel lines where there's one, but the second one is kind of laid down right over top of it. In other words, the same equation. And so we have to ask ourselves, okay, well, what's going on here? Well, here's the key. I have the same slope, so it's either this or this. Now I'm going to look at the b. And in this one, you can see that the b is a negative 4, whereas over here the b is a positive 4. So these are not the same equation. And what that means is they have different y-intercepts. And that means it's got to look like this, right? This line will cross at positive 4, whereas this line crosses at negative 4. They're parallel, they have the same slope, but they have different b's, which means they never touch. If you've got same a with a different b, then you are dealing with parallel lines that never, never, never touch. If you had same A, same B, well, then you'd be dealing with lines that overlay each other and would have infinite solutions. But that's not the case because we can see our B's are different. We're dealing with same A, different B. You can write that down on a memory aid. If you've got the same A with different B's, they never touch. And if you've got the same A with the same B, they always touch. If you have different A's, they touch once, never twice.